Hi, my name is Srijit Balakrishnan. I'm a PhD student at the School of Computing in NUS. I'm co-supervised by Dr. Brian and Dr. Hannah. Do you remember the fable of the Midas touch? King Midas once wished for everything he touches to turn gold. His wish was granted, and everything he touched indeed turned gold. Unfortunately, this included his food, and he eventually starved to death. I believe it's not an overstatement that we all understand what the king was trying to achieve with this wish. We understand his intentions. But this story also makes us realize how difficult it is to verbalize this intention to avoid such tragic endings. A similar problem plagues today's AI decision making systems. It's very hard to tell an AI system precisely what we want it to achieve. And as with King Midas, a poorly specified intention can lead to unexpected and sometimes dangerous actions by the AI system. Now, we do have a solution to this problem. Instead of specifying the intention behind a task, why not let the AI agent observe an expert performing this task? The agent can then infer the intention from these expert demonstrations. This paradigm is called learning from demonstrations. My thesis focuses on a family of algorithms under this paradigm called inverse reinforcement learning, or IRL. Under IRL, the intentions are cast as rewards that the expert is chasing. Hence, the IRL problem becomes inferring these rewards from expert demonstrations. Traditional IRL algorithms suffer from few challenges. In particular, there are more than one reward function that can explain the observed behavior of the expert. And without additional information, this ambiguity cannot be resolved. To address this, we developed BOIRL, a new IRL algorithm based on the popular Bayesian optimization technique. This work was published at the NeurIPS 2020 conference. BOIRL outputs the likelihood of the expert trajectories across various rewards so that we can identify more than one solution. In addition, BOIRL also outputs any uncertainty associated with these likelihoods so that these solutions can be explored further using techniques like active learning. Below are some of the results showcasing the likelihood of expert trajectories indicated by the color across various two-dimensional rewards. It can be seen that our method captures the likelihood very close to the ground truth when compared to the competition. Even though these results are promising, we must address one more challenge before applying BOIRL to real-life scenarios. In particular, real-life decisions are seldom made by naively optimizing narrow performance criteria like the reward. It's usually done within constraints set by broader societal concerns such as fairness. If your expert is acting fairly under some unknown fairness principle, then the task of inferring the expert's reward becomes more complex. Take a look at this example. Here you have a fictitious government trying to decide whether it should subsidize the healthcare of its citizens. On the right, we see the decisions made by the government for the male and female subcategory. And as you can see, under most fairness principles, the government has decided to deny the subsidy for both male and female. This complicates the reward inference problem, as the upset demonstration can now be explained by multiple fairness principles. Hence, we need an IRL algorithm that accounts for the presence of these fairness principles. This work is currently in progress, and we expect to publish our algorithm and results soon. To sidestep a bit, this diagram is generated by a new decision-making framework that we developed known as skills. Why do we need skills? Consider the original IRL problem. We are trying to find valid combinations of rewards and fairness that can explain the observed behavior. To do so, we need to generate optimal decisions under various fairness principles during the training. Scales achieves this by mapping various fairness principles into components of decision making in a standard and straightforward manner. We invite you to read our paper published in AIES 2022. I would like to discuss further details of my work with you. So if interested, please do contact me at the links provided. You can also scan the QR code for my Google Scholar profile, where you will find the papers mentioned previously. Thank you.